Welcome to this video on the topic of logical thinking. In this video, we'll be having a look at two things. The first thing being, what is an atomic instruction? And then secondly, we're going to use our knowledge of atomic instructions to be able to do some abstract programming. But before we can do any of that, we need to first revise what is a computer program. Now, a computer program is composed of three components. There's an input, there's a process, and there's an output. The way in which this works is we feed inputs into our process, where the process is going to carry out a number of instructions to change the input into a form to form the output. So our input is usually quite distinct from our output. Now, this leads to our first question in the lesson. How do we define the process? Now, following on from our previous lesson, we were having a look at computer programming languages. Now, typically speaking, we use a computer programming language to be able to define a process, of which we have different sorts of programming languages. We have languages that are low in abstraction, so they're closer to what the computer processor might communicate in. So we've got an assembly language. The complexities of using a computer assembly language is such that processors require more instructions to be adequately defined. And furthermore, they're less like spoken languages and therefore they are harder to understand. In contrast, we can work with languages that are highly abstracted. So a language that might be like that is Python. So with the Python programming language, what you're going to find is that it's easier to express ideas and concepts in a more succinct way because the instructions themselves, they're defined in such a way that they carry out larger tasks. As a result, what you're going to find is that languages that are high in abstraction are going to be closer to spoken languages and therefore they are easier to work with. The downside is that you're removing yourself away from the actual function of a computer processor per se, but that's a topic for another lesson. Now, where we're focusing on in this lesson is we're moving from this high abstraction level here, and we're going to focus on the low abstraction level here. So when we discuss about the complexity of instructions, for say in an assembly language, what we're talking about are instructions that are very close to what a computer processor would understand. What we're finding is we're working with instructions like add, multiply, go to, instructions that are very basic like that. Now, when we have an instruction and we break it down to its smaller parts so it can no longer be broken down any further, what we have is something called an atomic instruction. Atomic coming from the definition of the word, a finite or irreducible unit in a larger system. So we're dealing with instructions that can no longer be split into smaller instructions. Now, this concept here is important because when we're doing programming on various languages, or if we're trying to define a program like seen over here, it's important that the instructions we're using are understandable by the target process or the target machine that's going to execute the instruction itself. Now, in terms of being a human, for example, we're able to think in very abstract terms. So if we're doing something as simple as making a sandwich, then we're quite capable in understanding instructions like cut the bread, slice the vegetables, add the ingredients. It's quite simple to us. However, if we try to use those sort of instructions on, say, for example, a machine or a computer, it's not going to understand because the definition of slice of bread is not defined in terms of a computer instruction. Now, what we want to do is we want to have a look at how we can define processes using this idea of an atomic instruction. This can be done in 7 unique steps. The idea of defining process can be first carried out by firstly drawing the system or drawing the system that you want to write a program for. So you're going to have your inputs, your process, and your output. You're going to define the diagram itself for the process you want to carry out. After that, you're going to list all your inputs, followed by listing all your outputs. And here's where we start to hit the complexities of defining the process itself. At step 4, you must identify and list all instructions that make up a process. Now at this point in time, you're not going to be at an atomic level because it's only the first run through of defining all of your instructions. Rather, what we're going to do in the subsequent steps, so 5 and 6, is we're going to start making all of the instructions atomic. So, step 5, for each instruction, break into smaller parts. If an instruction was broken in the last step, repeat the previous step, else progress to the next step. So what you're going to find is that when you get to step 6, you go back to step 5, you look at every instruction and you try and break it down into smaller parts until you finally reach the point in which it's atomic. At which point, when every single instruction is at an atomic level, you finish. Now, applying this, what we're going to do is we're going to define a program for making a sandwich. Now, looking at step 1 on our list here, what we need to do is we need to draw the system. So my input. Now I don't want to have process here. Rather, what I want to have here is make sandwich. Now next step is what I need to do is list all of my inputs. What I had on my sandwich today was I got myself some tomato. I got myself some avocado. And onion, chili paste, mayo, salt and pepper, and finally I used Turkish bread to make the sandwich. Now next step is we need to list the outputs. Now for my sandwich, based on what I have here, is I'm actually going to make a toasted sandwich. So looking at what we've got so far, we've got our inputs, we have our outputs, and now of course what we need to do is we have to start the process of defining our process. So looking back at step 4, step 4 says we need to identify and list all instructions that make up our process. Now because we're only trying to define a basic understanding of how we carry out the process of making a sandwich, chances are on the first run I'm not going to do a very good job. I'm going to list some of the steps involved, but they're not going to be at an atomic level, and that's okay. So the first idea I had for making my sandwich was I said, and what we've got here is a weakly defined process of how we might go about defining our sandwich. So we're going to get the bread, add the ingredients, and then cook. Now, we might think that this is a really succinct process and it's foolproof, but let's have a look at some sandwiches you could possibly get. So the first sandwich is, well, okay, it's not the sandwich I would make, but look at how they've done it. If we look at this, we've got the bread, we've got the ingredients hanging off the bottom slice of bread, and then the top slice of bread. So, although it still matches the information we have here, minus the idea of cooking it, it's not really a sandwich we'd want. It's been poorly crafted. Going across, we have a sandwich that's a burger, so a burger is a sort of sandwich, but without proper definition, the bun itself has been placed erroneously on the burger. As a result, the sandwich is still valid in that you've got all the ingredients, but the process didn't define how to put the ingredients together properly. So you've got something that you'd need to modify before you'd want to eat it. Going across, you have another sandwich. It looks like it could be a toasted sandwich. It's got the aluminium foil. However, the definition of how we apply the ingredients inside the layers of bread has been poorly defined, and you've got too little ingredients going on inside. Moving across, you have an inappropriate amount of mayonnaise added to this particular sandwich. It probably tastes good, but it would be too messy to eat nonetheless. Looking across, we have a sandwich. Now, this person has gone for the more traditional sandwich in that you slice it in half. However, they have not defined the slicing process correctly in that they have sliced it in an asynchronous manner, in that this slice over here is vastly smaller than this slice over here. To be honest, I'm not so sure why you would want to use a sandwich that's been implemented like this. Might have some meaning to it, but in the context I'm looking at over here, it's not going to be a viable solution. And the final sandwich we're looking at, now this is an interesting one. This one, the user has gone to remove the bread altogether, and they've replaced it with what looks to be zucchini. Yeah, I believe it's zucchini, not cucumber here. If it's cucumber, it would be a very wet sandwich. But the zucchini here, they've used that as the bread. Now, I guess that's valid depending on the inputs you're feeding into the process. This is probably the best the computer could do to process the inputs. But in this context, there should be some form of checking to make sure that we've got bread there. Alright, so now that we've had a look at why we need to refine our process, let's go about breaking these steps into atomic steps so that we're going to get a properly defined sandwich at the end result. So, from step 4, I'm going to go, for each instruction, break into smaller parts. So if I can break an instruction up, I'm going to break it. Now going down, what I'm going to do is I'm going to go process number 2, and we're in step 5 now. And the next definition I had for this particular process is I decided to break this guy over here into 2 steps. So we're going to go 1 and 2. Now the first step was I'm going to get the bread, but what I'm going to do is I'm going to slice the bread. I decided that I needed to add the ingredients still. And then finally step 4, I said cook. Right. So the difference between the first process and the second process is steps 1 in the first one and steps 1 and 2 in the second one. Because we've defined the idea that we need to slice the bread, comparing the result of what we could get from process 1 to process 2. Process 1, there's always the opportunity that we're going to get a sandwich where it could look something along the lines. It could be something similar to the nature of this one over here. So the ingredients themselves have just been placed in a very haphazard way around the bread. What we want is the ingredients inside the bread. By slicing it in 2, you're going to get a sandwich where it's not like an open sandwich. Alright, now looking back at step 6, we have to, if an instruction was broken into the last step, repeat previous step. So we're going to try and break this down even further. So I'll go process, and this will be my 3rd attempt at defining the process. We will have 5 instructions, and the first 2 instructions, they remain unchanged. We're just going to get the bread and we're going to slice the bread. Nothing too complicated about that. Now the next one is going to be chop ingredients, followed by add ingredients, followed by close the sandwich, and finally cook. So we've gone from just add ingredients to now chop and add. And we've gone from simply cook to close and then cook. So we've broken these instructions down into more atomic steps. So we're looking at what happens in between instructions and we're breaking it down further. Now reviewing the process that we've got going on in this 3rd attempt over here, I believe we could go 1 step further. And processes 4 to 5, well, I'm going to give order to the addition of ingredients. Now, the most sensible order I could think of when making my sandwich is, it's all about how you're going to add these ingredients. So I say add chili paste. If you want the chili paste on the bun itself, if you pour it in the middle of the sandwich, you're going to have all sorts of difficulty trying to spread it. So if you try and spread it on onions, for example, it's not going to work. It's just going to be a big mess, and we don't want that. After that, the logical choice is adding the avocado, because you're still going to have the texture of the bun to smear the avocado onto. So we're adding the trickiest ingredients first. From there, we're going to put the tomato on. So the tomato is going to sit on top of the avocado. There's no problem with that. Followed by adding some salt to give the tomato some taste, and then followed up with some pepper. Moving on, we're going to add the onion. So the onion is going to sit lightly on top of the salt and peppered tomato. And then finally you add the mayo. So the mayo comes out of a squirt bottle, so it's quite easy to add the mayonnaise onto the sandwich ingredients. There doesn't really have to be anything that you're fastening it to. You just squeeze it on and it will happily sit there. From there, you're able to easily close your sandwich. And finally, you're going to cook the sandwich. And thus, what I've been able to define here is a process we can use to transform our inputs, seen over here, into a toasted sandwich. Alright, so this is the first part of being able to define a process. What we're now going to do is this visual step over here. It's not the easiest thing to look at. What we're going to do is we're going to draw something called an activity diagram. Now, an activity diagram is a figure we use in actual programming to show how a process is defined. Now, the way in which it works is, first thing we're going to do is we're going to draw a little circle, and we're going to shade it in. And this is going to denote the start of our process. From there, I'm going to name it make sandwich, like so. Now the next part is we look for the first step in our process that we've defined, and in our case it's going to be get the bread. So what I'm going to do is I'm going to go down slightly and I'm going to say get bread. Then I'm going to draw it, a little box with rounded edges on the box. Now, after what might have felt like an eternity, we reached the conclusion of defining our make sandwich process. The way in which we finish this off is we draw a little arrow, another circle, and then we put the terminating dot inside it. So this terminates the process and lets us know that we are finished. So what we've got here is our definition of make sandwich. Now, in summary, what we had to look at in this lesson was firstly, we had a look at the definition of a simple computer programmer. We had a look at the simple definition of a computer program, that being something that's defined by an input, an output, and its process. We then reviewed the idea of abstraction, which took us to the notion of atomic and an atomic instruction. From there, we then looked at this 7-step process of defining what goes on in a process to change our input into our output, and then we carried out this 7-part process to making a sandwich.